Class. In Chapter 7, we're going to look at linear programming. What you see here is a template that can help you build your problems. I want you to use this template. I want you to analyze this template. I want you to copy it. I want you to use it over and over and over again. Okay, you can use it on the assignments, on the exams. Please, not only you have to use it. I mean, you must use it. If you don't use it, I guarantee you a lot of problems coming your way. Um, I will not be able to give you feedback properly because I won't know what it is that you're doing. So just use my template here, and when time comes, which will be soon, you will be able to expand it. As you can see here, I only have two unknowns, which x1 and x2, but in the future you'll have 15, 20 unknowns. And as you can see, I only have 5 constraints, but in the future, you'll have, I don't know, 60 constraints maybe, or even more. So the problem that you're looking at right now, this is an example of maximization. And in this case, I just wrote here the problem, which is the same as the one on the slides. So you can just follow along. You can see how I do it on the slides, and you can see how I do it here. Okay, so this is how it's built, right? I'm just going to go cell by cell, and I'm going to show you what each of these cells has. And when I do that, I want you to, when I click on a cell, like this, I want you to pay attention up here, because that's what that is going to tell you what's in that cell. If it's a formula, it will display the formula. Okay, so this is how we do it. For a problem where we have two constraints, and the first factor for x1 is 5, the second factor for x2 is 7, you're going to put them right here. Okay, so these are the coefficients, the factors 5 and 7. Then right underneath, there's nothing. All right, you see how I'm clicking here and there's nothing in the form, those are empty. This is where Excel is going to write the answer to the problem. Okay, so you leave those two blank. Right? Here comes the first key piece, the Z. The Z is the formula that associates your coefficients to the different answers that Excel is going to try for you. Okay, so I'm going to click on it. Look at this thing. Let me tell you what it is. The formula is called sum product. What it does, it takes two arrays, two ranges, which are this range and that range, and it multiplies each of the pieces by the piece that corresponds, which in this case will be the one below. It multiplies 5 times whatever is in this cell plus 7 times whatever is in this cell. Okay, that's what it's going to do. Okay, so E5 to F5, and that's the first range. If you double click on it, you'll see it. So the blue range is multiplied with the red, using the red range. Okay. So let me show you. If I artificially create an answer, let's say it's 1. So you see what it did is 5 times 1 plus 7 times a blank, which is 0, therefore 5. But if I put another blank, another 1 here, now it's 12. 5 times 1 plus 7 times 1. Look what happens if I put a 2. Now you have 5 times 1 plus 7 times 2, which is 14. So 14 plus 5 is 19. Okay, so take that out. Now down here, the constraints. These are your constraints right here. Okay, I'm going to move them down here so you can see them. See? Okay, x1 less or equal to 6. Okay, so you're just going to write 1, which is the factor in front of x1, right? Is 1 times x1. And then you put a 0 because there's no x2. On the next line, you put a 2, that's the factor for the x1. And then you put a 3, which is a factor for the x2. If you had a negative sign here, you will put a negative sign right there, but you don't. In this case, you don't, but you definitely will in other problems. And then you put the sign less or equal to 19. and so on and so forth. Down here, these two are also very important. These are what we call the non-negativity constraints. This is what tells Excel that the answer is positive, that is not negative. So Excel, don't go into the negative world and looking for an answer. The answer cannot be there. It's positive. If you think about it, in the world that we work, that we live, technically there are no negatives, right? There's no negative action. There's no negative revenue. I know what you're thinking. Negative revenue would be you owe the money, but not really, not mathematically. That's not the case. So just always add the non-negativities. I'll say this over and over again. Don't worry. Okay, now down here, this is a copy of the constraints. Okay, see how it looks? It looks kind of the same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then we call it left-hand side, right-hand side. LHS, left-hand side, right-hand side. So it looks kind of like a copy, but not really. It's missing something, right? Let me show you. On the first cell, this one, okay, you're going to use, once again, the sum product formula to multiply this range up here, the range where Excel is going to enter the solution, which in this case is red on my screen, is going to sum and multiply the range below it. So it's going to be this times this plus this times this. Okay, you see that? Now look at this piece. You see how I entered dollar signs in front of the column and then in front of the row, and I did it again. What happens is, if you don't do that and you write the formula, let me show. I'll just show you. Let's say I delete. Let's say that you're doing this, right? And imagine you're doing 20, 30 constraints. Okay, and now I am going to remove the dollar signs. I'm just going to tell Excel. Yeah. I'm going to tell Excel that that's it. Okay, that is actually correct. That's exactly what you want to do. You want to multiply the solutions times this range. Okay, and then you're like, all right, all I have to do now is just copy and paste below, just drag down, right? Okay, I already see some issues down here. They should all be 0. Let's see what happened. So the first one is correct. Yeah, but look what happens to the second one. Look, yes, it's the blue range, which is this range. That is true. That is correct. But look what happened to the red, the range for the solutions. It moved down. It should be up here, but it came down. That's because you just dragged the formula without putting the dollar signs. Look what happens when you get to constraint 5. Look, you're multiplying rows inside of the constraints above, and it shouldn't be that way. It should be this way. All right. So in Excel, to get rid of that issue, to fix that issue, this is what we do. If you place a dollar sign in front of the address for the cells, like I'm doing right now, you see how I'm entering dollar signs in front of the column and in front of the row. Then, let me delete this. You can drag down, and Excel will continue moving the first range, but not the second range. So look, now for constraint 2, you're multiplying constraint 2 times the solution, constraint 3, third by the solution, and so on and so forth. Class, trust me, many of you are going to be emailing me late at night wondering why this is not working for you. It's because you did this and you forgot to put the dollar signs in the range, and that's one of the issues. Okay. Another common issue is that you're going to forget to add the non-negativity constraint. But again, I will tell you that a few more times. Okay. So the next step, we're going to go to data up on your ribbon, data, and you're going to look for the solver command. If the solver command is not there, I posted instructions on how to get the solver command to appear on your ribbon. So what we're going to do now is we're going to click Solver, and we get this menu. Regardless of which version of Excel you're using, yes, this might be different. All the menus, the ribbons might be different, but this particular window has not changed in many years. It's still the same. So let's start from the top. You're going to set the objective. You can click here. You can do it in different ways. You can type it in, but doesn't matter. You're going to set the objective to Z, which is this cell right here. Okay, that's all I did. I just told Excel that the objective is going to be right in this cell. This is the cell with the first sum product formula. Then I'm going to tell Excel the behavior that I want Excel to operate in. I want Excel to maximize the objective. I wanted to find the maximum possible answer for my problem given the set of this set of constraints. Okay, click max. You can obviously you can see it, sneak preview here. On to the next, which will be a minimum and value of. By doing what? By changing the following variable cells. These two in this case. These are the two cells that are going to change. These are the solutions. Okay. And then we're going to enter the constraint. I already entered the constraints here, but you can definitely, you should try it on your own using this very particular template to make sure that you get the same answer. So the first one, change. Whoop, where did it go? Oh, there it is. I don't know why it went. Okay. So cell reference. Okay, my constraints. One trick that is that saves you a lot of time, if you can identify multiple constraints with the same sign, with the same inequality, like these three, you see how all three are less or equal to something else, then you don't have to enter one constraint for each constraint. You can enter multiple ones at a time. And that's what I'm doing here. See, I'm going to select these three. Okay, sorry, I didn't mean that. Not there. These three right here, okay, not up here, but here where the sum product formula is, okay, less or equal to these three. And Excel knows, just from entering it this way, it knows that because you enter ranges, it knows that you're saying this one less or equal to this one less or equal to this one less or equal to that one. And you click OK. And there's one more that you need to enter because, look, you have the non-negativity constraints right here, x1 greater or equal to 0 and x2 greater or equal to 0. So I'm going to enter them. Is these two down here greater or equal to these two? And click OK. So that's it. I enter my constraint. Now I'm going to show you something that, just in case you didn't know how crazy I am, maybe you haven't met me in the classroom, but I'm a little paranoid about certain things, and this is one of them. I just hate forgetting about the non-negativity constraint. The last two, the x1 greater or equal to 0 and the x2 greater or equal to 0. I know it's here, but just in case, Excel gives us a chance to just hit this check mark right here and be done. This check mark and that last row that I enter here are identical. They do the same thing. Do me a favor, use both. I do, because in case I forget one, the other one will catch my my mistake. So just use both. Okay, so check on that, and then Simplex LP. I don't know what yours is going to have as a default. Make sure that you have Simplex LP, linear programming. Okay, and now just hit solve. You're gonna get this little window, and for now, later on, we're gonna do something with this window, but for now, for just the time being, just click OK. It goes away. Of course, if you did it right, it looks like this. If there's something wrong, it's going to tell you there was an error. Please review. So I'm gonna click OK, and there's your answer. For this problem, the way you get to the maximum answer, the optimal maximization of this problem is 46, and the way you get to that is by using 5x1 and 3x2. Now, on the next tab is the same problem, but in case you're trying to minimize, and this one is also on my slides. Just very quickly, I'll just show you that everything is the same, kind of. I mean, the constraints are a little different. Oh, look, I forgot. Make sure it will be okay because I have it here, so it will still work. But I just don't like it that way. And oh, look, somehow it defaulted back to this. Okay, it should be simplex LP. Hit minimize here instead of maximizing, and there's your answer. For this problem, the minimum answer will be found at 17.6, and that would be reached by using 3.2x1 and 0.8x2.